let's take a look at some of the properties that we've looked at to this point of operations. So some of these are more common than others that you have talked about before. So the big ones for us are going to be associative and commutative and distributive. And probably we want to remember reflexive at least. So those kind of the big four. We'll get these two. I want to make sure we'll cover associative, commutative, and distributive, and we'll cover these others so that you can maybe get some additional bonus points on the test. So first off, let's look at number one. Number one is an example of the associative property. So number one is the associative property. Well, what does that mean? Well, the associative property is all about how we associate numbers together. And we associate numbers together using our parentheses. We group them. So the associative property is all about grouping. And in our particular problem, we have got two identical statements, two identical expressions on either side of the equal sign, except for one thing. So over here we have 4 plus x plus y, and over here we have 4 plus x plus y. The only thing that has changed is the way that we group them. The order hasn't changed. Nothing else has changed, only how we've grouped them in parentheses. This is the associative property. So anytime you look at an expression and the only thing that has changed from one side to the other is how they're grouped in parentheses, that's the associative property. Now if we look down at number two, this is a very specific kind of property. It is called the transitive property. So this is the transitive property. And, whoops, I'm going to give you an example of that real quick to kind of explain what that is. The transitive property may be kind of like the most complicated one, but it's fairly easy. The transitive property says this: if A is equal to B and B is equal to C, then A is equal to C. All it's doing, you'll notice it's saying, well, I know that A is equal to B. I also know that C is equal to B. So if A is equal to B and C is equal to B, they're both equal to B, that means they both must be equal to each other. That's what we've done here. We see that the square root of 49 is equal to 7. So the square root of 49 is equal to 7. We also see that 7 is equal to 3 plus 4. Both of these things are equal to 7. Square root of 49 and 3 plus 4. Therefore, they both must be equal to each other. And that is the transitive property. The next one we have is we have m times n times 1. This is known as the identity property. The identity property is just about multiplying by 1. It's called the multiplicative identity. The multiplicative identity means anytime in multiplication that you multiply by 1, you get the same value back. So if we multiply m times n times 1, we get m times n. That's the identity property. It would work the same way if we said 9 times 1, right? Because 9 times 1 is going to give us 9. Or a times 1 is going to give us a. That is the identity property. The next one's fairly obvious too. This one is all about 0. It's called the 0 property. Notice that we're multiplying by 0 in this problem. We're taking an expression x plus 3, we're multiplying it by 0, and we're getting 0. The 0 property says, guess what? Anytime you multiply something by 0, you get 0. Whether it's 7 times 0, it's going to be 0, or b times 0, it's going to be 0, or x plus 3 times 0, the 0 property. Down here, we have an example of what's called the commutative property. Now, this is the one you'll remember from the past, 6th grade, hopefully. In this one, we have two expressions that use the same terms and the same operators, x plus 2 plus y, and 2 plus x plus y. They're all being added. The only thing that has changed between these two is the position of the individual numbers. Notice the grouping is the same. X plus 2 is grouped together over here. X plus 2 is grouped here. And x plus 2 is grouped here. The only thing that's changed is the order of the numbers. We know that this is the commutative property because commute means to move. If I commute from home to work, that means I drive from home to work. Or I ride a train from home to work. I'm commuting. I'm moving from one place to another. In this case, the two terms are changing places. This is the commutative property, all about movement. Up here at number 6, this is called the inverse property. Now remember that the inverse of a thing is always what you get when you flip it upside down. In this case, 2 is actually 2 over 1. If you remember that, 2 is always, as a fraction, is 2 over 1. Its inverse, then, is 1 over 2, which is what we have here. We have 2 over 1 being multiplied by 1 over 2. Anytime you multiply a number by its inverse, by its flipped upside down version, you're going to get 1. So if I was to take, for example, 1/2, I did 1/2. If I was to take 2/3, right? 2/3 times 3 over 2. I've multiplied 2/3 by its inverse, right? I flipped it upside down. That gives me 6 over 6, which is 1. That is the inverse property. Anytime you multiply a number by its inverse, or a term by its inverse, then you will get 1. The next property is the reflexive property. It's the easiest one. It says that if you have a thing equal to itself, it's going to be equal. 4 is going to be equal to 4. 5 is going to be equal to 5. A is going to be equal to A, the reflexive property. Now, this is also a version of the inverse property. This is called the additive inverse. This was the multiplicative inverse, right? Because we're using it with multiplication. This is the additive inverse property. So we have the inverse property again. It's just that this one is done with addition. Now, the additive inverse of a number, is its opposite. So, for example, the additive inverse of 5 is -5. Additive inverse of -4 is 4. If we take a number and we add its inverse, right? If I was to say 5 plus -5, what do I get? I get 0. -4 plus 4, I get 0. 10k squared plus -10k squared is going to give me 0. That's the inverse property. It's not the 0 property. I'm not multiplying by 0. I'm adding the additive inverse, and I'm getting 0. This is the one you definitely have to remember for sure. This is the distributive property. Distributive property right here at this one. So we've got distributive property here. You should know this very well. Its actual title is the distributive property of multiplication over addition. What that means is we have a number here that's being added. It's in parentheses, grouped together, and then we're multiplying a number by that. The multiplication is being done over the addition, right? Addition first and then multiplication. But this allows us to do 5 times x plus 5 times 7, right? We multiply this by both of these terms, and then we get 5x plus 35. That's the distributive property. And then lastly, we have one down here. This is -7v is equal to 28. If that's true, then 28 also has to be equal to -7v. If 3 plus 1 is equal to 4, then obviously, if you take 4, it's going to be equal to 3.1, right? These two things have to make sense. This is called the symmetric property. It's symmetric. On both sides, it's the same thing. If you flip it around, turn it upside down, turn it backwards, not upside down, turn it backwards, then you get the same thing. That's the symmetric property. And then finally, one we didn't talk about in class, but one we'll talk about briefly tomorrow is called the closure property. The closure property is actually really simple. It says, if you can take a number from one set, let's say the set of real numbers, right? We'll take the set of real numbers. That's all of the numbers that we have ever thought of. And we want to know if it's closed under a certain operation, right? So closed under addition would mean that if you add a number, if you take a real number and you add another real number to it, you're always going to get a real number. If that's true, then this is closed under addition. Now that's true, right? If we take 4 plus 3, we're always going to get another real number, right? Take a 4, which is a real number, and add a real number, we're always going to get a real number. We're never going to get a non-real number. What if we were to say the natural numbers, for example? If we take a natural number and we subtract a natural number, will we always get a natural number, right? Is Are the natural numbers closed under subtraction? If we subtract any natural number, will we get another natural number? No, it's not closed. And this is why. So if we were to take 2 and subtract 2, we would get 0. The natural numbers don't include 0. 0 is a whole number. The natural numbers are not closed, so not closed under subtraction. The same would be true if we were to, say, take the whole numbers, right? We could take the whole numbers and find that they are also not closed under subtraction. Because if I was to take the number 0 and subtract 3 from it, I would get -3. And -3 is not a whole number. It's an integer. It's not closed under subtraction. The whole numbers are not closed under subtraction. Neither are the natural numbers. But the real numbers are. So that's all our different properties. And I think that's it.